All right, guys, take a look. So this first one, does this feel at all like simplifying radicals to anybody? Do you see the example I gave, log base 6 to 12? 6 to what power is 12? I have no freaking idea. It's sort of like the square root of 12. Do you know what the square root of 12 is? I can guess, but I don't know. And then you can break 12 up though. I can break 12 up. In this case, I'm going to break it as 2 and 6 because the base is 6 of the logarithm. So it feels a little bit like simplifying a radical, making it match with what the thing is being asked to do something with. Log base 6, so make the 6 show up. So here, log base 3 of 3x, so it's in your face. The only way to break up 3x is 3 times x. So then how do we kind of rewrite this using the property? Yeah, log base 3 of one of these plus log base 3 of the other. Because this is adding powers, which is what I do when I multiply things with like bases. So then what's log base 3 of 3? 1. What's log base 3 of x? No clue. So that's the part that definitely feels like radical. Something is left inside because I don't know what this shit to do with it, but the other thing can be simplified. Now this way seems to be the more useful way in general. Because what can I do with this now? I'm adding powers, which means I must have been multiplying the things inside. And log base 12 of 12 is 1, because 12 to the first power is 12. I love it. I like it. So that's a little bit like if I had the cube root of 3 times the cube root of 9. Can I do either one of those on its own? No. I don't know what the cube root of 3 is. I don't know what the cube root of 9 is. But I get the cube root of 27, which I now know. They kind of filled each other in. This did the same thing. They kind of filled each other in. And then this is the same way, just log base 4 of what? 1/3 of 12. Which is log base 4 of 4, which is 1. Great. I like it. Alright, and then this one should feel very similar to that one. Really. So now I'm dividing, which means what do I do with the powers on each? Subtraction. So log base 3 of 3 minus log base 3 of 5. Log base 3 of 3 is 1. Log base 3 of 5 is no clue. I like it. You could approximate it. What's log base 3 of 5 got to be between? 1 and 2, because 3 to the first is 3, 3 to the 9, 5 is between 3 and 9. There you go. Exactly like approximating square roots. You know, we got right. This guy's now it's going the other way. I'm subtracting powers, so I must have been doing what inside? Dividing those insides. So I get log base 5 of, which is, that's all right, 2. I don't even know, I love math, but I can understand it. It's not the most exciting thing in the world, so don't worry about it. Now this one, there's several different ways to look at it. First off, you got to realize the same way we have a square root symbol, we don't put a 2 there because it's the most used root. Log base 10 is the most used logarithm. So we don't put a 10 on just to save time. If there is no base, I know it's a base 10. There is no number, I know it's a number 2 in there. So I could do this a couple different ways. If I'm following this rule, it would be log 1 minus log 10. Log of anything 1 is going to be what? Log base anything 1? 0. You raise anything to the 0 power to get 1. And what's log base 10 to 10? 1. So we get negative 1. Now what's the quicker way to do this? If the base is 10, what power do I use to make it become 1/10? A negative 1 power. Same answer we just got, right? So math has got to be self-consistent, meaning if you choose another path but do it legally, it's got to come out to be the same answer at the end. How did he get to 0? That's a property we know of logarithms. What's the only power that I can use on anything to make it become 1? What do I raise anything to make it become 1? 0. Yeah. Like, and real quick, let me just, that still seems to be some trouble with quite a few people. If I put a 1 here, right? There's a 1 there. Right? How many x's are here? How many x's do you see here? You guys are like, I don't know anymore, man. Just go with me for a second. I want to show you. Yeah, I see no x's, right?
Yeah.
So that would be no x to the 0. I multiply by x. Now I see 1x. And sure enough, if I multiply this by x to the first, I get x to the first. So the reason that anything to the 0 power is 1 is because that's what I'm left with. If I pull all the variables away, I'm left with that coefficient of 1. If I have no variables, I just have that 1 that's always floating there. That's why anything to the 0 power is 1. Period. That's why.
How do you get 2 on that one?
Where are we at? Sorry. Here.
Yeah.
What do I raise 5 to get 25?
Oh.
Second power. Yeah. So the outcome of a logarithm is always a power. Okay. So here, the very first one is already written with the inside to a power. So what can I do with that 2? Just take it out front. Bam. I lock it. So what about this guy? Is it written in the right way yet? No, I don't see a power on the inside. I think it's like a first power that comes down. Ooh, I didn't do anything really. But how can I rewrite square root of x? X to the 1 half. And then that 1/2 power can be written in front. I like it. And then finally, this guy was really, once you survive this guy, you're like, what the shit? But is this written in the form of the inside is something to a power? Yeah. Is the power pretty? No. Can you write that power? Yeah. Because that power is going to happen to it. It's going to just come down. Square root of r log base w e. Man. So let me show you a concrete example of something here, what this is trying to say. Sorry, you guys didn't finish right now. Let me show you a concrete example of this. What is log base, let's say base 3 of 81? 4. Because how many 3's do you take to make 81? Multiplication wise is 4 3's multiplied. I like it. Now, what's 1/2 of that? Well, log base 3 of 81 is 4, right? So what's 1/2 of 4? 2. Now, what's another way to look at this? Can't that 1/2 just come up here? Right, so what's another way to write 1/2 log 381 is log base 3 of 81 to the 1/2. And what's 81 to the 1/2? Square root of 81, which is 9. And what's log base 3 of 9? Freaking 2, right? So if I apply the square root on the inside, it's going to cut the power by 1/2 that I need. Because what does the square root do? Cuts the power in half. So really, that's really all this is saying. Whatever log base 5 of x is, log base 5 of the square root of x is going to be 1/2 of it. Because it's going to cut the power in half. That's another way to look at this. You have to look at them all in all the different ways. No, you pick the way that makes the most sense to you. So you can remember the rule easier. Okay. Here, let's do a few more. Slightly more longer examples up here.
Okay. So this way makes a lot of sense because a lot of math is about consolidation, trying to get things together. Do we have any property for twice a log minus 3 times a log? No. We have a property for log of something minus log of something with the same base, right? So what's kind of like in the way for me to try to consolidate all this shit into one log? What's in my way? Well, you do it. What's in? If only this was log MW minus log MA. That's easy. Why is that easy? How can I rewrite this? Log M W over A. Why was this easy and this not so easy? Because these don't have what? Coefficients. The coefficients are in my way. How can I get the coefficients out of my way? Well, where can I put the 2? Put it up here. Okay, good. So if they want you to consolidate a logarithmic expression into one log, first thing is get the coefficients the hell out the way. You ain't got no property about 2 logs and 3 logs. Get those out of the way. Log, okay, I can do that. So log base m of w squared minus log m third plus log m. I like it. You can write b to the 1 half or just square root of b. Sweet. Now between these two, what's going to happen? Yeah, w squared over a third. Now between these two, what's going to, I'm sorry. At least, no, I didn't. Between these two, what's going to happen? Multiplication. So it'll be log, because I'm adding power, so I must have been multiplying this stuff on the inside. Log base m of, multiply this and this, right? So w squared, square root of b, over a cubed. I like it. Now what's the kind of a semi-shortcut here? What's the only negative thing in this whole thing? The one that has the a in it, right? So notice how it's the only thing that ended up on the bottom, of course, because it's the only thing that's got a negative power, really. I could have done this. I could have done this. A negative 3 would have flipped down on the bottom. I don't know if you guys... Or subtraction of 2 logs means division. I mean, you see how they all line up with each other. It's self-coherent. Just because you write it one way doesn't make it different. So this should look like very mathematical, something you're very used to. All this spread out shit, and then we consolidate it into one big thing. But to be honest, very often going the other way is also useful. So you just have to be able to go both ways with this in this section, right? They're going to give you stuff that looks like this. They're going to ask you to consolidate it. They're going to give you stuff that looks like this, and they're going to ask you to expand it. All right. So if I saw this. Yeah, I like it. And what should be the very first thing you do? So I'm talking about logarithms. It's the very first thing you should do. I don't know if you guys all are. What's the first thing you think about? Sure. Scream. That's good. Go somewhere and scream. Get all that out of your system, right?
Log v w to the third minus log v 5 square root x.
All right. Okay, I can deal with that. What can I do with this here?
Subtract.
So let me say this, minus, now how do I rewrite log base b of this product? Yep, log b is 5, plus. The most common mistake is people forget that minus has to apply to everything I get from this. That minus has to apply to everything I get from that. Not just pieces of it. It doesn't make any sense. And then the last couple things I could do is anything with the power is really the exact opposite thing we did here, right? First thing I did was get the coefficients up. The last thing I do here is get these powers down. And what can I do with this? This would be x to the 1/2, so 1/2 can come out front. I like it. So now if you had to take this and add it to some log-based BWs, you have some like terms here waiting for you instead of it being all stuck inside here. That's why sometimes it's good to go this way. To break it up. But if I can break it up, that means I can put it back together. I can put it back together. Aw. Okay, so you gotta get in there and try those out. One more thing, and then we'll take a break. Yes.
On the first one, why is the W is higher than the B squared and no B squared at the bottom?
Where's b squared?
Oh,
Square root of b.
square root of B.
Why would there be a square root on the bottom?
You multiply them?
Yes, and what's on the bottom currently of this? Because there is nothing down there really, but there is always a 1.
Oh, okay.
So it's that times that over that times that. Yeah, it's only square root of b. It's not square root of b over square root of b because then it would be 1. Right? Yeah. You can only have a square root of b in one place. All right. Or do you guys want to take a break right now? You're like, I want to go home. No, that's not an option. It's too bad. All right, well, let's take a break now. Looks like you guys could probably use one. Come back at 1:45. Then we'll finish out chapter 12, look at section 13.1, and then we'll head out.